325,000 people. That's how many have been forced out of their homes across France and Spain in the last few weeks alone. Not from a war, not from a flood, but from fire. Right now, wildfires are tearing through southern and western Europe. In Spain alone, more than 150,000 hectares have burned since the start of this year, 6 times the area destroyed during the same period last year. Combined, France and Spain have had to evacuate over 325,000 people from their homes. And this isn't just a European story, parts of North America are dealing with the same pattern, just for slightly different reasons underneath. And this isn't a one-off bad summer on either continent. Wildfires destroyed 2.2 million hectares of land across Europe. Last year alone, up from 1.4 million hectares just 3 years before that. That's a 57% increase in land burned in just 4 years. So the real question isn't what sparked this one fire or what sparked that one. It's bigger than that. Why does this keep happening on 2 different continents year after year? That's what we're actually digging into. Let's start with where things actually stand. Since early July, wildfires have burned across southern and western Europe, with France and Spain hit hardest. Madrid's regional government declared a national emergency after fires near the capital forced 10,000 people to evacuate. This has come at a real human cost. The deadliest single fire of the season tore through the Almeria region in southern Spain, and at least 13 people lost their lives. Meanwhile, in North America, a strong seasonal weather pattern has been driving hotter, drier air across the United States this year, with drought still affecting roughly 40% of the country as of late June. The largest fires this year have concentrated in drought-hit areas like Georgia, Florida, Colorado, and North Texas. Here's where most coverage stops too early. When people ask what's causing these fires, there are really 2 different questions hiding in there. What actually sparks any single fire? And why the whole system has become so much more likely to catch and spread in the first place? In Europe, that second question has a specific decades-long answer. Since the mid-1800s, rural populations across the Mediterranean have been steadily moving to cities. In Corsica's Baleine region, for example, the number of working farms dropped 20% between 1950 and 1970 alone. And that pattern repeated across Spain, Portugal, and southern France for well over a century. That abandoned farmland didn't stay empty. It grew into dense, unmanaged shrubland and forest, and a lot of it was replanted with fast-growing conifer trees for timber, which happened to be especially flammable. Where farms and grazing animals used to naturally break up the landscape into patches, there's now a continuous, connected carpet of dry fuel stretching across huge areas. And here's the detail that surprises most people. Researchers estimate roughly 96% of Mediterranean wildfires are started by human activity, not lightning. A spark at the roadside, a downed power line, a discarded cigarette, sometimes deliberate arson. So it's not that nature is randomly striking more often. It's that there are constant small opportunities for a spark, landing in a landscape that's never been more connected and flammable. North America's version of this pattern comes from a completely different direction, even though the end result looks similar. For roughly a century, US and Canadian fire policy was built around one goal: put out every wildfire as fast as possible. That worked in the short term, but forests in this region historically relied on smaller, more frequent fires to naturally clear out dead wood and thick undergrowth. Suppressing every single fire, including the small, low-intensity ones, meant that material never got cleared. It just kept piling up year after year for decades. On top of that, bark beetle infestations and invasive species like cheatgrass have killed off or dried out even more vegetation, adding still more flammable material standing in these forests. NASA's own research points to earlier snowmelt, warmer nighttime temperatures, and decreasing summer rainfall as the main drivers behind increasing fire weather across the American West specifically. Put together, you get forests holding decades' worth of unburned fuel, arriving right as the conditions get hotter and drier for longer stretches each year. Canada's 2023 fire season, its worst on record, burned about 45 million acres, roughly 5% of the country's entire forest area. One study estimated that smoke from those fires alone may have contributed to as many as 33,000 premature deaths in the United States, though that's a single study's estimate rather than a settled figure. So here's the actual answer to why does this keep happening every year? Stated as precisely as it can be. In Europe, decades of people leaving rural land let fuel quietly connect itself across the landscape, while the vast majority of ignitions still come from ordinary human activity. In North America, a century of suppressing every fire let fuel quietly pile up inside forests that used to burn it off naturally and regularly. In both cases, climate change didn't create that fuel. What it's doing is supplying the ignition-friendly conditions, the heat, the dryness, the longer fire seasons, that make decades' worth of pre-existing fuel far more likely to erupt into the kind of large, fast-moving fires we're seeing right now on both continents. So, to bring it together, this isn't one mysterious cause. It's decades of land use decisions on two different continents, quietly building up enormous reserves of flammable material long before this year's heat and drought ever arrived. The weather lights the match, the fuel was already there waiting. This is one of those random questions that isn't random at all once you actually look into it. If you want to support the people affected by these fires, local relief organizations in the affected regions are a good place to start. I'll see you in the next one.